All right, let's dive into a topic that trips up even seasoned C programmers. We're going to tackle it by solving a few classic puzzles. You know, the exact kind of stuff that pops up on exams and in job interviews. So you'll definitely want to stick around. Okay, let's get into it. So here is our first puzzle. We've got a global variable, x, and we set it to 1. But then, inside my function, we declare another variable, also named x, and set that one to 2. The function then prints x. The question is simple. What number actually gets printed to the screen? Go on, take a guess.
And the answer is 2. Now, if you guessed 1, don't worry, you have just stumbled into one of the most common pitfalls in C. So why? Why does the program pick the 2 instead of the 1? To really get that, we need to pull back the curtain on 2 core C concepts.
And the 2 ideas that unlock this whole thing are scope and lifetime. Now, they might sound kind of similar, but they actually control 2 very different aspects of a variable, where it can be seen and how long it actually exists.
First up, let's talk about scope. The easiest way to think about a variable's scope is to imagine it's the variable's home turf, its territory. It's the only part of the code where that variable's name actually means something. Step outside that territory and it's like the variable is completely invisible. So in our puzzle, we had 2 competing territories. The global X has what's called file scope. Its territory is the entire file. But the local X has block scope. Its territory is only inside those curly braces of my function. And here's the rule. When there's an overlap, the more local, more specific variable always wins. It's a concept called shadowing. The local X basically casts a shadow over the global X, hiding it from view.
Okay, so that's scope. The other half of the equation is lifetime. And this is all about a variable's actual lifespan. It's not about where you can see it. It's about how long it physically exists in the computer's memory. Now, most of your local variables have what's called an automatic lifetime. They're born the moment their function is called, and they're destroyed the instant that function ends. Poof, they're gone. Global variables, on the other hand, have a static lifetime. They're created when the program first boots up, and they stick around in memory until the very end. Now here's where it gets really cool. We can actually bend these rules. There's a special keyword in C that can give a normal, temporary, local variable a kind of superpower, letting it live way longer than it's supposed to. And that keyword is static. Let's look at another puzzle to see what I mean. We've got a super simple function called counter. All it does is create a variable count, set it to 0, add 1 to it, and print it. So if we call this function 3 times in a row, what do you think the output's going to be? 111. Makes sense, right? Because count is a regular local variable. It has an automatic lifetime. It's created and set to 0, it gets printed, and then it's immediately destroyed. Every single time. It has absolutely no memory of what happened before. But watch this. What happens if we make one tiny change? We're just going to add the static keyword right in front of that variable declaration. Everything else is exactly the same. We call it 3 times again. What's the output now? And boom, the new output is 1, 2, 3. The counter suddenly has a memory. It actually remembers its value between each call. This right here is the superpower of the static keyword. So here's what static is actually doing. It gives a local variable a static lifetime, just like a global one. That means it's created only once when the program starts, and it sticks around forever. That line static int count equals 0, it only really runs the very first time the function is called. But, and this is the critical part, its scope is still local. It's a private, secret variable that only that one function can see, but it never ever forgets its value. Okay, now that we have a good handle on scope and lifetime, let's put it to the test with one of the most classic and most dangerous exam traps in all of C programming. Take a look at this function. It creates a local variable, local var, and then it returns the memory address of that variable. Now, the C compiler will look at this and say, yep, looks good to me. It'll compile without any errors. But is this code actually safe? No, absolutely not. This is a ticking time bomb. It leads to something C programmers fear more than anything: undefined behavior. And what that means is your program might crash, it might spit out bizarre results, or worst of all, it might seem to work perfectly fine right up until it fails at the most critical moment. So why is this so incredibly bad? Well, it all comes back to lifetime. Remember, local var has an automatic lifetime. The very second that function finishes, that variable is destroyed, gone. The memory it was using is now free game. But we've returned a pointer to that now dead memory location. This is what's known as a dangling pointer. It's pointing to rubble and trying to use it as a recipe for disaster. So the golden rule is never, ever, ever return the address of a local variable.
So let's zoom out and put all these pieces together, because this isn't just a collection of random rules. It's a framework for how to think about variables in C. And the reason we obsess over these rules isn't just to pass a test. This stuff is the absolute bedrock of writing C code that's safe, predictable, and doesn't crash. In C, managing memory correctly is job number 1.
This chart right here is your ultimate cheat sheet. It puts it all together beautifully. A normal local variable has a tiny block scope and a temporary lifetime. A global variable is the complete opposite, huge file-wide scope, and it lives for the entire program. And then there's our special hybrid, the static local. It gets the best of both worlds, the strict private scope of a local variable, but the permanent program-long lifetime of a global. That combination is what makes it such a powerful and safe tool in your C toolbox. If you only take one single thing away from this, please let it be this. Scope is about visibility. Where can I see the variable's name? Lifetime is about existence. For how long is this variable actually alive in memory? They are not the same thing. Understanding that difference is everything.
And that leads me to a final question for you to chew on. Since a static local and a global variable both live for the entire run of the program, they can often solve similar problems. But the static variable is hidden away inside one function, while the global is out there for everyone to see and touch. So, when would you choose one over the other? And how does making that choice affect how safe and how easy to understand your code becomes? Something to think about. Thanks for joining me.